Okay, so question number 3. The carbon tetrabromide molecule is what of the following? A polar molecule with polar bonds, a nonpolar molecule with polar bonds, a nonpolar molecule with nonpolar bonds, or a polar molecule with nonpolar bonds. Okay, so first let's show what carbon tetrabromide looks like just by drawing out its Lewis structure. So drawing the Lewis structure will help us visualize what the molecule would look like to see if it has any lone pairs or if there were any dipole moments, if they cancel out. So we first need to calculate the total number of valence electrons for this molecule. So carbon has 4 and bromine has 7. And since there are 4 bromine atoms, we multiply this by 4. And if we add these up, we get a total of 32 valence electrons. So carbon will most likely be our central atom. And we can draw 4 single bonds to our bromines. Okay, so this is a skeletal structure. And I can now add the lone pairs that our bromine atoms will have. So if I count out how many electrons I've drawn so far, where each bond contains 2 bonding electrons, then we can see that I have my 32 total number of valence electrons. So I don't need to add any more, and I know that this is my final Lewis structure. So to find out whether or not the molecule is polar or nonpolar, we first need to find out the polarity of the bonds. So this will also help us answer the multiple choice since we need to know if the bonds are polar or nonpolar. So to determine the bond polarity, we need to calculate the difference in electronegativities. So this can be shortened as delta En. The difference in electronegativity between carbon and bromine. So for example, if our difference in electronegativity is less than or equal to 0.4, then we know we have a nonpolar bond. And if our difference in electronegativity is greater than 0.4, but less than 1.69, then we know we have a polar bond. And when we have an ionic bond, this is when the difference in electronegativity would be greater than 1.69. But since we don't have any metals in this compound, we know that our bond is not ionic. Okay, so now let's calculate the difference in electronegativity for both for carbon and bromine. So let's look up electronegativity values. And we'll see that our bromine only has an electronegativity value of 2.8, and carbon's electronegativity is 2.5. So the difference is only 0.3. So therefore we have a nonpolar bond. Let's look at another reference just in case, since a lot of the times people will have different values. So here, 2.98, 2.55, yeah, so it's still around the same value. Let me calculate that. So depending on what source you have, sometimes they have different electronegativity values, but you can see that it would still be a nonpolar bond. So we know that the bonds are nonpolar. So even if there was like a slight dipole moment, we would see it going towards the bromines. And this is when we would also analyze the molecular shape of our compound as well. So to find the molecular shape, we need to look at our central carbon, and we see that it has 0 lone pairs and 4 bonded atoms. So if we see a VSEPR table, when you have 0 lone pairs and 4 bonded atoms, we have a tetrahedral shape and electron geometry. So we know that this is a symmetrical molecule. And even though our bonds are nonpolar, we can even just double check to see if the molecule would be nonpolar, just also because these dipole moments would cancel each other out. So I'm just going to say that the molecule is nonpolar as well. Okay, so let's see what the junior tutor said. I guess our option would be C, a nonpolar molecule with polar bonds, nonpolar bonds. So therefore, C. Okay, so they said that the carbon tetrabromide is a nonpolar with polar bonds. So surprisingly, the bonds are nonpolar. So the electronegativity difference between carbon and bromine is less than 0.5. Therefore, the bonds would be considered nonpolar as well. The explanation about dipole moments is correct. Our overall molecule, nonpolar due to nonpolar bonds and the symmetrical shape.